Simplifying radicals. To simplify radicals, it's like reducing fractions. Except instead of knowing factors, we need to know not just factors, we need to know what is a perfect square or a perfect cube, depending on the radical. In this class, we pretty much deal with squares. I'm still going to talk about perfect cubes. Well, there's a list, and I'm going to show you how to make the list. You guys can continue on. I'm going to change color for each column. I didn't hit the erase button. So X is counting 1, 2, 3, 4. So what are perfect squares? Perfect squares are going to be the green numbers. Well, how do you do it? Go 1 times 1 is 1. You take the number times itself, because what is a square? 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25, and so forth. Let's add a few more. I just don't have a lot of room. So 6 times 6 is 36, 49, and that is not the complete list. How far does a square go? How far can you count? That's how many squares, perfect squares there are, because you can still square whatever number. It does not end. So if that's a partial list of perfect squares, let's talk perfect cubes. Well, I'm going to do the same purpose, except now I'm going to multiply the blue times the green. So 1 times 1 is 1. 2 times 4 is 8. 3 times 9 is 27. 4 times 4 is 64. 5 times 5 is 125. And this is where I slow down. 6 times 6 is 216. And 7 times 7 is 343. Yeah, 343. So that is a partial list of perfect cubes. Reason why we focus on these is because in a previous video, I talked about how you can use your calculator. Well, what's the square root of 54? You can key that into your calculator, and you're going to find it's not an exact number. I just keyed it in mine, and I see 7.3484692, blah, blah, blah. That is called an approximate answer, because we're going to have to round that. Your calculator is even rounding it. It only goes out so many decimals. It's not an exact answer. So when we want exact answers, when it's not a perfect square, we do is what, like with fractions, we simplify it. And we simplify it based on the factors of 54, but the factors of 54 we're really worried about are the ones that have a perfect square. So 54, what number goes into 54 as a factor? Well, I can rewrite 54 as 2 times 27, but 27 on the perfect square list? No. But I can also write it as 9 times 6. Because of that, I can square root the 9. The square root of 9 is what? 3. That's the reason why you don't know these quickly. I would make a list like this and just keep going a little bit further. And it helps. Can I square root 6? Not exactly. So it stays behind. So radical 54 simplified is 3 radical 6. This is a simplifying of radicals, because some of your instructions are going to say exact answers, and students try to do this. that decimal thing because they only use their calculator. No, can't do that. And yes, some of your more higher power calculators, you can tell it to give it to me. But we need some understanding here. So let's try another one. How about radical 72? You want? Pause it, but I'm going to continue explaining it. Pause it, see if you can do it on your own. So radical 72 can be rewritten as 2 times 36. That I can clean up. Can I take square root 2? No, so it stays behind. Can I take care of square root 36? The answer is yes. Square root of 36 is 6. So radical 72 in its exact form is 6 radical 2. Hopefully this helps. This is simplifying radicals.